The next method of factoring that we are going to learn is called factoring by grouping. And we're going to go a little bit out of order as following the book, but I'm going to teach some of the factoring strategies a little bit differently from the way that the book teaches it, and we need to know how to do factoring by grouping in order to do that. So factoring by grouping only works when there are 4 terms, and you need to know how to find GCFs, which is what we just did before in 7.4 while we were still at school. So the first problem is going to say x to the third plus 3x squared plus 2x plus 6. And I'm going to group the first 2 terms together and the second 2 terms together. And I'm going to look for the GCF of the red group only and the GCF of the blue group only. And I'm going to factor them out. And so when I look at x to the third plus 3x squared, what they have in common is x squared. X to the third means x times x times x. 3x squared means 3 times x times x. There's 2 x's, and over here there's 3. So what they have in common is the x squared. So I factor that out front. In the first term, I'm left with an x when I divide out an x squared, and in the second term, I'm left with plus 3. So that's how I factor the red group. And then the blue group, I have to look for what do 2x and 6 have in common. Well, their greatest common factor is 2. So I'm going to factor out a 2. And if it's okay with you, I'm also going to recognize that I'm factoring out a positive 2. It's going to help me write my final answer. So when I factor out the 2 and I divide out the 2, factor, divide, I factor that out, I'm left with an x, and then 6 divided by 2 is 3. Now what needs to happen in order for us to use factoring by grouping is what's in the parentheses has to match. If it doesn't, then either I did something wrong, maybe I didn't factor out the greatest common factor, maybe I just factored out a common factor, or it's just not factorable by grouping, which we probably won't encounter too much of that in this section that's called factoring by grouping. And so now that I have the same quantity in each term. This first term says x squared times the quantity x plus 3. And the second term says 2 times the quantity x plus 3. So what is it that they have in common? The quantity x plus 3. So I'm going to factor the quantity x plus 3 out front, and I'm going to write down whatever's left over in each term, which in the first term I'm left with an x squared. In the second term I'm left with a plus 2. And so it's the factored version of this, is x plus 3 times x squared plus 2. And that is a pattern that we'll recognize that I don't need to write this x plus 3 twice. Maybe I can answer questions separately about why that is, but I only write it once because it's the common factor that I write out front. 2x and 6, I factored out a 2 out of both of the terms, but I only wrote 2 one time. So when I factor the quantity x plus 3 out of both terms, I only write it one time. And then I write what's left over, which is x squared plus 2. The next problem that we're going to do is a to the third plus 3a squared plus a plus 3. So again, I'm going to group my first 2 terms and my second 2 terms. And I'm going to look for what is the GCF of only the red group. And that answer is a squared. So when I factor out an a squared, what am I left with in the first term? A. What am I left with in the second term? 3. A plus 3. Now when I look at this second set here, this blue group, I'm trying to decide what they have in common that I can factor out front. And it doesn't look like they have anything in common to factor out front. And so what that means is that the greatest common factor is 1. It is a positive 1, and I'm going to write that. I need that 1 as kind of a placeholder, and I'll show you why that is. But if nothing, it looks like it has nothing in common, then the GCF is 1. And I am going to write it out front that I'm factoring out a 1. When I factor out a 1, I'm just dividing by 1, so it doesn't change anything. A plus 3, which is good because I want these parentheses to match. Once they match, I factor that quantity out front. So I get the quantity a plus 3, and then left over in each term, I get the other quantity. So I get a squared plus 1. And this is the answer. And what I'm going to do is actually foil this. I'm going to go back. So this is the answer. Just so you know, this is the answer. Now I'm just going to show you why that +1 was so necessary. So let's say I want to make sure, I'm going to make sure I wrote down that problem right, but I want to be able to FOIL this out and get back to this original polynomial that they gave me. And when I do that, a times a squared is a to the third, a times 1 is plus a, 3 times a squared is 3a squared, 3 times 1 is plus 3. And I can rearrange the terms, write it in standard form, put the 3a squared first and then the a, and then the plus 3, and then it is going to match the original problem. So that is what I want. If I didn't put that +1, let's say I didn't put the +1 and I just put a plus 3 and a squared, and I didn't put the +1 because I didn't think I needed it. When I try to factor or FOIL that, when I FOIL this, I really don't have anything to FOIL. I just have the distributive property with an a squared. So a times a squared is a to the third, 3 times a squared is 3a squared. But notice how I'm missing the other half of the problem. So I need this 1 as a placeholder if I factor it out. The next problem, 3z to the third plus 2z minus 12z squared minus 8. So see if you can come up with the GCF of 3z to the third plus 2z. Z. And when I factor it out, what am I left with in parentheses? 3z squared plus 2. Okay, so there are a couple of things to recognize when I go to do the blue group. I want what's in the parentheses to match. I want the parentheses to have a positive 3z squared and a positive 2. And right now I'm looking at some negative numbers. So if I want positive numbers in there, I might need to factor out the negative. So the greatest common factor between 12 and 8, you might think it's 2, but it's not. It's 4. 4 is the biggest number that goes into 12 and goes into 8. So when I factor out a 4, I want to make sure that what's in the parentheses is positive. So for that reason, I'm going to factor out a -4, which means I'm dividing each term by a -4. Negative 12z squared divided by -4. The two negatives cancel out and I get 3z squared. And then positive 3z squared. And then -8 divided by -4 is positive 2. And so what's in the parentheses do match exactly. So I can write that quantity out front, 3z squared plus 2. And then in parentheses, I put the terms that are left over, which is the z minus 4. And this is the answer. And so if some of my terms are negative, that's because there was a negative in those parentheses somewhere. Okay, so GCF is not ever going to go away. All of the factoring problems that we do, we need to be on the lookout for a GCF in general. So I'm actually going to do this problem 2 separate ways. So let's say that I just do this problem by factoring by grouping. So I split it into my 2 groups. I say, what do 3x to the 4th and 3x to the 3rd have in common? Well, they have a 3x to the 3rd. And when I divide 3x to the 4th divided by 3x to the 3rd, 3 divided by 3 is 1, and x to the 4th divided by x to the 3rd is just x. When I divide each term by 3x to the 3rd, when I take 3x to the 3rd and divide by 3x to the 3rd and everything cancels out, I'm dividing here. 3 divided by 3 is 1. X to the 3rd divided by x to the 3rd is 1. So as important as the other 1 was, we needed that as kind of the placeholder. I didn't want to forget about this one. I also don't want to just ignore that one. I need to keep that +1 there. And then in the blue group, I'm looking at what do they have in common. The GCF of 6x squared and 6x is 6x, and it's a positive 6x. So I'm going to divide by 6x, divide by 6x. 6x squared divided by 6x is x, and 6x divided by 6x is 1. So I'm going to make sure to put that +1 as kind of a placeholder, but really it's important to be there for the similar reasons as to why it was important the other time. If I want to, make sure that this is the right answer, I need the whole problem. I need that plus 1. So whatever is the set that's the same, I factor it out front, x plus 1, and then what I have left over in each term is 3x to the third plus 6x. Now this is on its way to being right, but it's actually not done. I have to be on the lookout for GCFs all the time. X and 1 have nothing in common, but if you look at 3x to the third and 6x, they have something in common still. They have a 3 and they have an x in common. So I need to factor that out. So I have in the first term just x squared, and in the second term plus 2. And so it's standard to write the monomial, which is the term with, or the polynomial with only one term out front. It doesn't really matter the order of the quantities because it's multiplication, it's the same. But it is standard to put the monomial out front. So this is the final answer. So this is not done. If there's something more in common. So 3x times x plus 1 times x squared plus 2. So what that means is that I could have looked at this whole polynomial first and recognized that they all share a 3 and they all share an x. So I'm going to do this problem a second way. I don't know if you can fast forward through this. You can figure that out, but I don't know how far to tell you to fast forward. But this is the same problem done a different way. So and here's what I'll say. Between these numbers here that we were working with, they weren't too big. They weren't too terrible, 3s and 6s and x squareds. But if it gets bigger and more complicated, it might be easier to do what I'm going to do here, which is look across the board. So I need a new color. Let's do orange. So I'm looking, that's not orange, that's orange. So I'm going to, oh, it's kind of orange. Oh, this is the one that I wanted. So I'm going to look at the whole thing, and I'm going to take the GCF out of the whole thing. So this entire polynomial, every single one of these 4 terms, I can factor out a 3, and every single one of these 4 terms, I can factor out an x. That has not happened before this problem. 3 and 2 and z, and see how this 8 doesn't have any z's on it? There was no GCF across the whole thing. There's no GCF across the whole thing on here, nor is there on here. But in this problem that we're doing, now there is. I can take out a 3x. So when I factor out a 3x, here I'm left with x to the third. The degree goes down by 1, plus x squared. And then 6 divided by 3 is 2. X squared divided by x is x. And 6x divided by 3x is plus 2. So I can start by factoring out that number or that term first. I want my orange again. Oh, I keep doing that. So what I'm going to do is draw an arrow because I'm going to ignore the 3x. For the rest of this problem, I'm going to ignore it, but I'm just going to recognize that my final answer is going to have a 3x in it. And now I'm going to go about it as normal. So I'm going to do factor by grouping, factor by grouping, group this into 2 separate groups, factor out what x to the third and x squared have in common. The answer is x squared. When I divide by x squared, x to the third divided by x squared is just x. Because if I start with 3 and I take out 2, I'm left with 1. X squared divided by x squared is 1. And I am going to put that plus 1 there as a placeholder. And then 2x plus 2, they have a 2 in common, a positive 2 in common. So I'm going to divide each of these terms by 2. And I'm left with x plus 1. So then I recognize the quantity that they have in common is x plus 1. In parentheses, I write what's left over, x squared plus 2. And what I don't want to forget to do is take this 3x, the arrow should have looked like this. Make sure that my 3x is in front of the final answer. And so what you will hopefully notice is that we do the problem two different ways, but we get the same answer. 3x times x plus 1 times x squared plus 2. So I would recommend taking the GCF out first if there is one across the entire thing, because I don't know, I may look at this and say, oh, I'm done, and then IXL drops me 10 points, and then I, realize that I forgot a GCF. So I'd rather take the GCFs out first if possible. So the other ways that this is going to get a little more complicated is they're going to throw a couple different letters at you. So this next problem says 2a squared plus 8ab minus 3a minus 12b. I'm still going to do this problem the same. I just have to realize that I have both a's and b's. So I'm going to split this into two groups. I'm going to decide what the GCF of 2a squared and 8ab is. Well, 2 and 8. Let's start with the numbers. The greatest common factor between 2 and 8 is 2. Next, let's look at the a's. So this term has two a's, a squared, a and a. This term has one a, so they both have an a that I can factor out. Both terms don't have a b, so I can't include b as part of my GCF. So what's left in the first term when I divide out a 2a is just a, and what's left in the second term when I divide by a 2a? Well, 8 divided by 2 is 4. The a's cancel, and then I'm left with a b. So I'm left with a plus 4b. So what's in the parentheses when I factor out the GCF in the blue group needs to also be a positive a plus 4b. So for that reason, I'm going to look at negative 3a and negative 12b. I need to know, first of all, the GCF between 3 and 12, which is 3. But if I want what's in the parentheses to be a positive a and ultimately a plus 4b, I need to factor out a negative 3. So when I factor out a negative 3, I'm left with, in the first term, negative divided by a negative cancel out and become positive, so 1a or just a, and then, so I'll write it, and then negative 12b divided by negative 3, negative 12 divided by negative 3 does become plus 4, and then that b there as well. And then I have what's in parentheses is the same, so a plus 4b is the same. The quantity is whatever's left over, which is 2a minus 3. So the answer is a plus 4b times 2a minus 3. And then the last one that we're going to do in this video is 3f to the third g minus 6f to the third plus 9f squared g minus 18f squared. Whoa. This looks overwhelming. Here's how I'm going to start this problem. I am going to look and see if there is anything, I'm going to get my orange pen, and I'm going to look and see if there is anything that all four terms have in common. Is there anything that all four terms have in common? So I look at 3, I look at negative 6, I look at 9, and I look at negative 18. And I say, what number goes into 3 and 6 and 9 and 18? And the answer to that question is 3. So I'm going to be dividing each of these terms by 3. I'm also going to look for letters that they all have in common. So what do they all have in common? Well, this here has 3 f's, f times f times f. This has 3 f's. This has 2 f's. And this has 2 f's. So they all have at least 2 f's. So f times f is f squared. So part of the greatest common factor is going to be f squared. And then I look at the g's. This term has g. This term doesn't have any, so it doesn't matter that this one does. That one doesn't either. So g is not part of the GCF across the board. So I'm going to divide each term by 3f squared. And I don't necessarily need to show this step if I can do this in my head, but sometimes it just helps to see the division. 3 divided by 3 is 1. F to the third over F squared, take out 2 of the F's, and so I'm left with F, and then the G didn't cancel, so I'm left with G. In the second term, 6 divided by 3, or more importantly, negative 6 divided by 3 is negative 2. And if there were 3 f's, that did say f to the third, divided by f squared, I'm left with f. In the third term, 9 divided by 3 is plus 3. The f squared and the f squared cancel out completely to be 1. I don't need to write times 1, but then I'm going to leave my g. And then in the last term, negative 18 divided by negative 3 is negative 6. And then f squared over f squared cancel out completely. And I'm just left with minus 6. And so when I do that, well, hold on. I don't want to lose the fact that my final answer has a 3f squared in it. Don't forget, my final answer is going to have a 3f squared. I don't take it out and get rid of it, but I am going to ignore it for the rest of this problem. So I'm going to do my grouping of my first 2 terms, do my grouping of the second 2 terms. What do fg minus 2f have in common? Well, number-wise, there's nothing, but both of them have an f. And when I factor out the f, in the first term I'm left with g, in the second term I'm left with minus 2. When I divide out the f, I'm left with g minus 2. In the blue group here, 3g minus 6, what they have in common is a 3. And if I'm trying to decide, should I take out a negative 3, should I take out a positive 3, just look at what I want this quantity to end up being. I want it to be a positive g minus 2. And so right now the signs are in that way. So I'm going to factor out a positive 3, because when I do that, I'm left with g minus 2. So what they have in common, I factor out front, g minus 2. The second quantity is what's left over in each term, which is f plus 3. And then what I can't forget is to bring my GCF from the whole thing, 3f squared. So this is the final answer. And so those are all the problems that we are going to do. So like I said, I want you to go on to IXL, the Algebra 1 level, and I want you to do AA7. And your goal is a 90% or a 90 SMART score.